Hi, welcome. We're going to talk about Chapter 9, Day 2, Surface Area of Pyramids and Cones. So whenever you have a pyramid, pyramids, first of all, they um, are a three-dimensional object. We call that a polyhedron. And each side is called, well, each side is a polygon, and each side here that is a triangle, these are called your lateral faces. Okay, so your lateral faces, when they come together and they meet, they make a lateral edge. So when you see this picture, there are four lateral faces, there are four lateral edges. In the bottom, which is a different shape, and for most of the problems that we do, it's going to be a square. This is called your base. So whenever the base and the lateral edge meet, that is called a base edge. And again, there are four of those. Now, there's a lot of terminology we have to learn. An altitude and a height is going to be the same thing. It comes out of the vertex at the top, straight down, and it always makes a 90-degree angle. And we'll talk more about that as we go along. Now, regular means all the sides are going to have the same measurement. So, like for your base, all these sides here are going to be the same. So, even if they don't tell you, you know that's going to be a square because all the sides are going to be the same and all the angles are also going to be the same. So, I'm going to go ahead and mark that. All right, so again, terminology wise, we have something called a height, which is a lowercase h. And that is like if when you're at the doctor's and you stand up nice and straight, and that is perpendicular. But we also have a thing called the slant height, and this is a lowercase l. And this is like if you're, a kid climbing up on play equipment and you're climbing up the side. It is not up straight. It's a slant height. It is slanted. Okay, but it makes a right angle with the base down here. So it is tricky. And we're going to have to learn how to distinguish from those. So the first question is define the area of the lateral face. So when you look at this picture, a lateral face is one triangle. So all the triangles should be the same. It doesn't really matter which one. So let's just pick one. All right, so let's get our bearings here. This line down here is labeled, this is your slant height. It is slanted, and that is lowercase l. This height that goes straight down in the middle, this is your height of it, like how tall it is. And S stands for side, so each side is going to be 300. Now this one's a little tricky. What happens is whenever you draw in this height or altitude, it goes to the center when it's a square. And what it does is it breaks this into half. So this right here is half of your side. So we know right away that this is half of 300. So it's 150 feet. Okay, so that's something we're going to have to draw in quite a bit. Now, why do we need to know that? Well, we're going to end up doing Pythagorean theorem a lot because if you notice, here, let me erase some stuff so we can see this. We have a right triangle here, and we know two sides of that triangle. We know this side here is 321 feet. We know this bottom is 150 feet. And we're going to solve for this slant height. Now, why do we need the slant height? Okay, so let's back it up even more. If I'm trying to solve for one lateral face, that is the area of a triangle. And from our last lesson, we know area of a triangle is base times height over 2. Now, so this across the bottom is your base, and we know our base is 300, and we need to know this. And for that face, that is the height. So it gets really tricky. The L, the slant height, is for the pyramid, but if you're looking at one lateral face, that's just a triangle. Okay, so a triangle has its own base and height. And that's where the confusion sets in. Okay, now let's go back to this Pythagorean thing. Can we solve for this? Of course we can. And I'm just going to redraw it down here. We know this is 150, this is 321, and we're going to solve for x. So I'm going to use Pythagorean. My hypotenuse is x, and my two legs are 321 and 150. All right, so let's use your calculator. 321 squared plus 150 squared is 125,541, and square root that, and we get an answer of 354.3. And I normally round off to the tenths for everything. So now to complete this problem, I'm going to take 1/2 times base times height. So my height in my base is 300 times, and I'm running out of space. Let's go over here. 354.3 all over 2. 300 times 354.3 divided by 2. So I get a final answer of, and it's a big answer, 53,145 feet squared. And that's just for one lateral face. Okay, pause if you need to. When you're ready, let's go. Now, we have a formula for this. Technically, you could find the area of all 4 lateral faces and find the area of the base and add them together. It's kind of tedious. So write this on your formula sheet, and we need to know what each letter stands for. Okay, so if you're not going to remember, write it down. Now, capital means the area of the base, or capital just means you're dealing with the base. So capital B means the area of your base. And capital P means the perimeter of the base. And L is your slant height. So what I like to do is I like to find all these pieces and parts before I begin. Okay, and so whenever we do these problems, just make sure you're writing out all your numbers, and then you're plugging it into your equation, and that way, if one number's off, it's very easy to find. Work should be very, very clear. All right, so let's actually do this. So surface area, and let's look at the formula again. Base plus 1/2 perimeter times slant height. Okay, so as I said, let's find the area of the base, let's find the perimeter of the base, and let's find the slant height before we do anything else. So we know that this base at the bottom is a square because it's regular. So for the area of the base, we know from our last lesson, a square has a side and then you just square it. So 11.2 squared is 125.44. Now my perimeter, you're just going to take the 11.2 and times it by 4 and get 44.8. And then your slant height is, now this is your slant height. It is the slanted number, so that is 17. So let's go and just plug it all in. 125.44 plus 1/2 times 44.8 times 17. Okay, so let's multiply some of this together. 0.5 times 44.8 times 17 is 380.8. Okay, now sometimes you might be asked, what is just the area of the base? So it's very clear at this point, this is the area of the base. What's this? This is the area of the lateral faces. Okay, so the same thing up here in this equation. B stands for base, we know that. So all of this is for the lateral faces. All right, so let's just add these two together and get your total surface area. 380.8. Okay, so I get an answer of 506.24 millimeters. Now we're finding the surface area. So is this millimeters, millimeters squared, or millimeters cubed? Now we're still using area. So this is millimeters squared. And that is your final answer. Now, surface area of cones. All right, so I know at first glance this looks probably more difficult, but it actually ends up being easier. R stands for radius, and that's stated here, and L still stands for slanted height. All right, so write this on your equation sheet. Pi r squared plus pi rl. Okay, so let's back up the train. What's pi r squared? Hopefully you know that. That is how you find the area of a circle. So the area of the circle is the base. So pi rl has to be this lateral part. So anytime you're finding surface area, and I actually like to use SA for surface area, it's always made above the base and the laterals. Okay, so pi r squared plus pi rl. Let's practice it. Now we are going to leave in terms of pi. All right, so if you don't know what that means your final answer will have a pi symbol in it. Okay, so it ends up being much easier. So I'm just going to write the pi symbol. Let's replace the radius. So my radius is 4. Draw your pi symbol. My radius is 4. And my slant height is right here. This is my slant height, and it is 6. Okay, so let's simplify both of these. So this is 16 pi plus 24 pi. So 16 plus 24 is 40. So what we're going to do is we're just going to leave it 40 pi. You treat pi kind of like a variable. Just pretend like it's an x. You just kind of bring it along. So my surface area is 40 pi inches squared. That's all you have to do. Okay, so this is the last slide, and what we're going to do is we're just going to try to find each of these. And you can pause it and try it. Okay, so let's try to get our bearings of some of this. So the height is the same thing as the altitude. And so that is this number that goes straight down and makes a 90 with the base. So that is 1 centimeter. So this is E. My slant height is the one that is actually slanted. It's right here. It is root 2, so it's B. And, I don't know why I skipped area of the base. Let's do the area of the base, which is 2 by 2, so it is 4 centimeters squared, so it is C. Now for lateral area and surface area, you should be able to tell the difference. Which one should be bigger? Because the lateral area is just the area of the 4 triangles. And the surface area is the 4 triangles plus the base. So we could kind of cheat a little bit and say, okay, the 4 triangles is probably going to be this. And if you're going to add the base back in, we know the area of the base is C, which is 4, and I'm taking this answer and adding 4. Okay, so those are the answers. Now, let's actually prove that. You knew I was going to say that. Okay, let's find the area of this triangle. So area is 1/2 base times height, or as you know from last lesson, base times height over 2. My base is 2, and my height here is √2, and it has to be over 2. Well, the 2's cancel out, so it's √2, and that is just one of the faces. So if there are 4 triangles here, you're going to actually times that by 4, and that's how they get 4√2. All right, and that is it. And for your homework, you're going to actually need this formula for the area of a hexagon. So again, put that on your formula sheet. And I know it says worksheet. It is a Canvas assignment, just like normal. And if you have any questions, feel free to send me a Canvas message or join a help session. Thanks.